Hi guys. So this video is going over the CPI worksheet. So if we read the first um, couple of sentences here, right, it says the consumer price index, called CPI, is a financial ratio that has to do with inflation. So we're told that the cost of goods and services typically rise each year. So for example, a movie ticket in 1990 that cost $6.50 will cost more in 2005, right? We can make this assumption. This is a fairly safe assumption to make, right? That costs keep rising each year, right? So it says thus a dollar in 1990. So notice how we can denote that as 1990 dollars, right, by putting a dollar sign behind it. So think of this as a unit, right? Was worth more than a dollar in 2005, right? So if we do 2005 with a dollar sign above it, or not above it, but after it, we can refer to this as $2005, right? So we're told here that it's helpful to think of $1990 and $2005 as different currency in much the same way that dollars and euros are different in currency, right? So when we compare dollars in 1990, 2005, or any other year, we think of those as different units, right? Surely they're both in dollars, but we have to think about them in different units because a dollar in 1990, let's say, is different than in 2005, right? So you can buy more with a dollar between those years, right? So that means they're not the same units in that sense. So we need to be able to convert between these currencies, and the CPI allows us to do that, right? So if I want to compare things in different years, right? So we're told that the CPI is a measure of the cost of a fixed basket of goods and services in a given year. This is called an index because it has arbitrarily been set to 100 for the cost of this basket in 1983 dollars, right? So these same goods and services would have then cost 130.7 in 1990 and 195.3 in 2005 dollars, right? So we'll come back to this in a minute. I just wanted to point out a resource that I gave you with if you're interested to find more about CPI. So I gave you this website through the Bureau of Labor Statistics, right? So this is housed within the United States Department of Labor, right? So this is a governmental website. But I have here, if you go to this website, this is like the main page for Consumer Price Index. If you scroll down, there's a link here for CPI Facts. So I think this is what's interesting, right? So here are 10 frequently asked questions, and if you click on that, you can see the appropriate answer. So one thing that I thought was interesting is number 7. I was curious, what goods and services are included in the CPI? So if we click on this, it'll give you information over that. So I would feel free, to browse over this and just check it out, right? Since you're a little bit familiar with what CPI is and kind of wrap your head around it, it'll make this part, I think this part of the class easier to know, right? So definitely check this out and read that over. All right. So going back to the notes, so let's see. So we were given this information, right? And then where I left off, so to convert the cost of a $6.50 movie ticket in 1990 to $2005, we can use a proportion to do this, right? Using CPI values, right? So we're given this table. So we've been provided with the CPI value in 1990 and the CPI value in 2005. So if I make a proportion, I can go from 130.7 over 195.3 equals 650 over x, right? Where this is x here, right? So that will answer up answer number 1, right? So what we have left to do is that we need to solve for x, right? So if we cross multiply, so x would be equal to 650 times 195.3 divided by 130.7, right? So if we plug this in the calculator, so take 6.5 times 195.3, oops, 0.3, and then divide that by 130.7. we get roughly $9.71. Right? So if a movie ticket costs $6.50 in 1990, right? If movie costs kept up with like inflation, we would assume that it would cost $9.71. Right? So then number 2, it says assume the ratio of euros to dollars is 4 euros to $5, right? So if you don't know this funky symbol, this is what they use for euros, right? Just like our dollar sign is for dollars, right? So it might seem weird because we're not used to that symbol, but that's what that represents, right? So it says what is more expensive? If we buy a mocha latte that costs 2 euros or one that costs $3.50, right? So I've personally never traveled out of the country, but I know people that have, and by my understanding is when you travel out of the country, you can typically pay for something in euros or pay for something in US dollars, right? By what I'm hearing, a lot of countries will accept US dollars, but they have different prices for each, right? So this might be helpful to know, well, which one would be a better deal, right? So if I had euros and I had dollars on hand, obviously I'm going to want to pay the least amount, right? So we can use this 4 to 5 ratio to convert from euros to dollars to figure this out, right? So we want to know. Essentially, we want to know how much does a 2 euro latte cost in US dollars, right? So we want to figure out X. So going from euros, we would do 4 to 5, right? So this is euro to US dollars. And then we have a $2 latte, which is in euros, and we have X here, right? So I can set up the proportion and solve. So X would equal, 5 times 2 divided by 4, right? So you should be able to do that in your head, but just in case you want to plug it in really quick, right? 5 times 2 is 10, and then if we divide that by 4, we get 2.5, right? So $2.50. Right? So 2 euros is equivalent to $2.50, right? Which is what we figured out. So the question is, which one's more expensive, right? Do we want to buy something that costs 2 euros or $3.50? So since both of these are now written in US dollars, so when I pay 2 euros, I'm essentially paying $2.50. So now that both of these are in the same units, we can compare, right? So the $2.50 is $1 less than the $3.50 latte. So it would be cheaper to buy it by 2 euros, right? So the question is, what is more expensive, right? So what's more so the $3.50 latte is more expensive. Right? Right, so we answered the question, right? So then number 3 is something kind of similar to that. So it says, which was more expensive if we have a $2 Starbucks mocha latte in 1990 or a $3.50 Starbucks mocha latte in 2005, right? So this is very similar to number 2. So number 2 isn't using the CPI, but it's just helping us understand the similarity of if we are converting between different currency. That's essentially the same thing if we're comparing within like US dollars but in different years, right? So trying to see that connection. So we're asked which was more expensive, $2 Starbucks mocha latte in 1990 or $3.50 Starbucks mocha latte in 2005, right? So again, we want to convert everything into the same units. So we were already given X here, right? So that's hinting at the fact that the question is trying to prompt us to convert the $2 Starbucks mocha latte in 1990 and convert that. What would that cost in 2005 dollars, right, using CPI. So we could do the opposite, right? I could take the 350 from 2005 and then convert that into 1990 dollars. But we don't have to do both, right? We could do one or the other because we're just comparing. So if I take 130.7, compare that to 195.3, right? So this is 1990 dollars compared to 2005 dollars, right? So then, so for 1990 dollars, we had a $2 mocha latte, and then in 2005, we don't know what that would cost, right? So we're trying to convert that into 2005 dollars. So now if I set up this proportion, solve this proportion, x would equal 195.3 times 2, and then we would divide that by 130.7, right? So we can use calculator really quick. So 195.3 times 2, right, and then divide that by 130.7. So we get roughly $2.99, right, if we round that, right? So I get approximately $2.99, so $2.99 would fill in here, right? So we're trying to see which one's more expensive. This would be more expensive, right? So even if we convert how much we paid in 1990 to 2005 dollars, we're still paying more than what we would have, even controlling for that different dollar amount, right? So we could say that the $2 latte in 1990 is cheaper, right? Or we could say the opposite, right? The $350 latte in 2005 is more expensive, right? Either way. All right, so then the last problem, number 4, we're looking at. So we have some information and then one more question. So it says the CPI allows us to compare data sets that involve monetary values over time. The amount of money the federal government collected, i.e., we call these receipts or taxes, look to have been increasing steadily in the following table. But in order to compare these values, we need to convert all three into one currency, right? So we can't just compare these values in their own year's currency. We want to compare them all in terms of $1990, $2000, or $2005, right? We need to pick one. But what the book is pointing out is that if we just look at these values just how they are, it looks that it's steadily rising, right? But again, this is not a fair accurate measure, right? It's not a good indication because it doesn't control for inflation, right? All right, so if we look at number 4, it says convert the 3 receipt values in the table to one currency using the CPI value. You can choose which currency to use and determine the year when the receipts are greatest when adjusted for inflation, right? So we can choose whatever year we want. We want to convert everything in terms of $1990, in terms of $2000, or $2005. So there's already an A here in $2005 and a B here for $2005 currency, and then obviously in 2005 this value is what the 2005 dollar amount would be, right? So I'm going to convert everything in terms of $2005. So if we look at part A, right, to set up this proportion, so I want to go from 1990 to $2005. Right, so I'm just writing here just as a reference. So I want to compare their CPIs on one side, right? So the CPI in 1990 was 130.7, and the CPI in 2005 was 195.3. Right, and then so the $1990, the actual value in 1990 was 1,032. And this is in billions, right? But since everything's in the same units, I don't have to worry about units. I can just use that value, right? So then now I need to solve for this unknown. So I'm going to use capital A as my variable, right? So A goes with this A down here. So setting this up, we would get A equals 195.3 times 1,032. And then we divide that by 130.7, right? So if we do this, right, so if we take we need to take 195.3 times 1,032 and then divide that by 130.7. We get 1,542.1 roughly, right? If we round that. So that value would go here, 1,542.1. So then now we can do part B. Right, so part B we would want to do something similar. So we want to take the $2,000 and convert it into 2005. Right, so we'd have $2,000. We want to convert that into $2,005. Right. So in 2000, the CPI was 172.2. The CPI from the table in 2005 was 195.3. So we can set up my proportion. So I'm going from $2,000 to 2005. So the 2005 would be my unknown. I'll use B for part B. And then the other value I need is how much did the 2000 actually cost in $2,000. That was 2,025. Oops. Right. So solve for B. So to solve for B, we would take 195.3 times 2,025, and then divide that by 172.2. Right. So 195.3 times 2025, and then divide that by 172.2. So we get roughly 2,296.6, right, is what I believe was shown there, right? So that value would go here, 2,296.6. So now on this last row, right, for $2,005, everything is in $2,005, right? So now it's fair to compare these. So if we compare, does it look like that everything was steadily increasing, right? So from 1990 to 2000, we have an increase, right? But from 2000 to 2005, we actually had a decrease in spending, right? Now that everything's in terms of the same currency. So we could say something like, so converting all receipts to $2,005, we see that in 2000 are greatest when adjusted for inflation, right? All right, so that's all I have for this worksheet.